All right, let's look at voltage spoofing with LiBCM. We've got it working now. I've got the IMA system here, and what we're going to do is we're going to just jump right into it. I'm just going to turn the key on here, and then I'm going to push some buttons here and not really explain it, which is okay. Okay. All right, we've now turned the car on. Cool, right? So what we have is anything that's sent here that's a P code will say P and then the code P1648, for example. None of these are P codes. These are other data that are sent on the same bus. This is LiBCM here. It's showing you the actual pack voltage and the spoofed pack voltage. And then the actual pack voltage is also measured here with the DMM as well, just for a sanity check. And we have two other signals we're measuring, which is VPN and the MCM-E connector. So there are three signals here that tell the MCM what the pack voltage is. There's BATSI, which is a digital signal. It's sent over this differential BATSI bus. There's VPN, which is generated by the IGBITs. So the IGBIT module actually has a 0 to 5 volt output, which is the actual pack voltage at the IGBIT driver divided by 52. So that's a 0 to 5 volt signal. And that, by default, just runs directly to the MCM. Now with LiBCM, it runs through LiBCM, so LiBCM can man in the middle it, so we can change the pack voltage. Now the third signal, so those two signals are fairly easy. The third signal is the MCM-E connector. Now MCM-E is the full pack voltage. So it's actually, if the pack's 180 volts, 180 volts are sent to the MCM through the MCM-E connector. Now we've spoofed that here. We have an opto isolator with a base that we tie to make it turn off quickly. We talked about that before. That was actually a headache getting that to work. And so now we PWM it. And so what you're seeing yellow here is the MCM-E. We're measuring it with a differential probe, which is a 500X probe. So this is 0, 50, 150, 180 volts. Boom. So VPN is the green signal here, and it's that 0 to 5 volt signal. It's going through a 10X probe. So what you can see here is I've got the car on or whatever, and this is the actual voltage and the spoofed voltage. So we can now say, 165 volts, and in real time, I just did that off screen on a computer. I just told the LiBCM, hey, I want you to spoof 165 volts on all three signals to the MCM. So we can do, 150 or 140. Can't do 40 though. We're gonna do S140. So now we have 140 volts. We could do 130 volts, so S130. And of course, what we want to get to based on Peter's findings is that magical 120 volts. This gives us maximum power here. So what you can see though is that the more I spoof MCM-E, the yellow one, the more error it has basically. It has this AC rider signal. Now that's not noise, it's actually the way we generate MCM-E. We're having to spoof it through a pulse width modulation train. So let me go back up to like S160 there, and you can see the pulse train is less there. Now we can increase the frequency of MCM-E, and so that's basically not even going to be an issue. You can see right now that it's 1, 2, 3, 4, so we're running at about a kilohertz on the MCM-E connector. We can change that up to like 30K or something, no problem there. Now VPN, on the other hand, on the Rev B hardware, I can't change the PWM frequency of VPN because the pin it's hooked up to is also what controls the timer for delay in Arduino. So if I change that, say, from 1 to 60 kilohertz, then it'll make all of the delays 60 times faster, which is not good. But anyway, it's working, which is great. We still need to drive around in the car. And I did want to point out that it doesn't matter what the pack voltage is here, as long as it's between about 67, maybe even like 65 and 94%, we can spoof a constant voltage. Now we're not going to do that at the end of the day. We're going to actually spoof a voltage that will be a function of the current. So if you step on the gas really hard and it gives it a lot of assist, we'll drop that voltage down so that the MCM will give it more current. But anyway, the function works. Fundamentally it works, and now we just need to figure out what voltages do we want to spoof and when. So that's voltage spoofing.